This is Lesson 5 of the Subnetting.net video series on how to subnet. This lesson shows you how to create a subnetting cheat sheet and explains how it works. In the first 4 lessons, we covered a lot of math, and much of it seemed like something you have to memorize. A subnetting cheat sheet reduces the amount of required memorization and makes it much easier to do subnetting calculations quickly and accurately. Now Kevin is going to show you how to make a subnetting cheat sheet.
In this video, I'm going to walk you through creating a subnetting cheat sheet. The process is pretty easy and it should only take you a few minutes to reproduce this on paper. The first step is to create a grid with 3 columns and 14 rows. Then label the columns bits, block size / exponent, and decimal mask value. In the bits column, start with the number 0 and count up to 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. For the block size / exponent column, begin at 1 and double each row all the way down. So 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048, and 4096. Finally, for the decimal mask column, start at the row parallel to 128 in the block size column and enter the number 128. From there, we take the value in the previous row and add it to the next value in the block size exponent row. In this case, we'll take 64 and add it to 128, which equals 192. Then 32 and 192 is 224, 224 and 16 is 240, 240 and 8 is 248, 248 and 4 is 252, 252 and 2 is 254, and finally 254 and 1 is 255. If you are studying for your CCNA or CCENT, you will receive a dry erase board at the testing center. We recommend creating this cheat sheet on the board as soon as you sit down to take the exam. Even if you're already tough at subnetting, the cheat sheet can reduce errors and helps keep things clear in your head.
Now that you know how to create the cheat sheet, practice creating it a few times on a blank piece of paper so you can make it quickly when you sit for the exam. Here are some important notes about the cheat sheet. But before we start, let's add a 0 to the decimal mask value. You don't need to write the 0 down on your sheet, but just remember that it's there. It still follows the same pattern. 0 plus 128 equals 128. 128 plus 64 equals 192, etc. Notice that the middle column is the powers of 2. 2 to the 0 is 1. 2 to the 2 is 4. 2 to the 4 is 16. 2 to the 10 is 1024. This column is also the subnet size when you know the number of host bits. If we have 10 host bits, our subnet size is 1024. Don't worry about block size just yet. We'll get to that in a moment. You can also use this cheat sheet to convert between shorthand and decimal subnet mask notation. Here's how. Whenever you have a subnet mask in shorthand, you want to divide it up into 4 groups of at most 8. For example, the subnet mask /21 equals 8 plus 8 plus 5 plus 0. Notice we just keep adding 8 until we can't anymore because it would be too high. /27 equals 8 plus 8 plus 8 plus 3. /12 equals 8 plus 4 plus 0 plus 0. Each of the 4 numbers represents the 4 octets of the decimal subnet mask. To figure out the decimal subnet mask, we subtract each of the 4 numbers from 8 and find the result in the bits column. Then slide over to the decimal mask value column. For example, our first number is 8. We subtract it from 8, which gives us 0. We find 0 in the bits column. And then slide over to the decimal mask value column, which is 255. And that's our first octet. Then we write 255 under the 8. The next 8 will also be 255, so we can write that one too. Now let's do the 5. 8 minus 5 is 3. The corresponding decimal mask value for 3 is 248, so we write that in the third octet position. The last number is 0. 8 minus 0 equals 8, and the corresponding decimal mask value is 0, which is our last octet. A couple of notes about this. Anytime you see an 8, you know it equals 255. Anytime you see a 0, you know it equals 0. That means that every decimal subnet mask is going to have at most one octet which you need to figure out. We call this the interesting octet. The other 3 will always be 255 or 0. This is why we don't need to actually write the 0 on the cheat sheet. Lastly, instead of subtracting each number from 8, you could alternatively count up the chart starting from 128, like this. 1, 2, 3, 4, 5. So the 5 corresponds to 248. Kevin will demonstrate this again in a moment. Let's use our chart to write out the other 2 examples shown here. For /27, the first 3 octets are all 255. The last octet is 8 minus 3 equals 5, which corresponds to 224, or we count up from 128. 1, 2, 3, which is 224. For /12, the first octet is 255, and the third and fourth octets are 0. For the 4, 8 minus 4 equals 4, which corresponds to 240, or, counting up, 1, 2, 3, 4, we land on 240, and we're done. Now here's Kevin showing you how to do basically the same thing, but slightly faster. Use whichever method you prefer.
What is the subnet mask corresponding to a shorthand of /14? With practice, you will eventually memorize these shorthand questions. Until then, we could use the cheat sheet. Since the given shorthand mask is greater than 8 and less than 16, we know we are working in the second octet. Since there are only 8 bits in an octet, or 0 through 7, this means the 8th bit on the cheat sheet represents the previous octet, which is all binary ones, or a /8. From there we have to count up. 9, 10, 11, 12, 13, and 14. Now we can move parallel to find the decimal mask. Simply plug this into the second octet and we are done. The answer is 255.252.0.0.
Now let's discuss the block size. The block size is basically just a mathematical tool which makes it easier to do subnetting quickly when dealing with more than 8 bits at a time. Here's an example question which will make it clear. What is the network ID of the 4th subnet in the network 172.20.0.0/21? To answer this, we could start by determining the subnet size. The number of host bits is 32 minus 21 equals 11. 11 host bits tells us that our subnet size is 2048. So now that we know the subnet size, we just need to multiply 2048 by 3 to get the starting IP address of the 4th subnet. Note we multiply by 3 because we're already at the first subnet, so we want to find the 3rd subnet after the starting subnet. Now the math is probably bringing back painful memories of lesson 3. But let's trudge through it anyway. 2048 times 3 equals 6144. And now we simply need to start at 172.20.0.0 and count 6144 IP addresses to get the answer. As we learned during our counting exercise in lesson 3, we know that every time we add 256, we increment the next octet by 1. So we can divide 6144 by 256, which equals 24, and then our answer is 172.20.24.0. But if you don't like doing that much math, you're in luck. That's where the block size comes in. Let's write down our subnet mask in decimal. /21 equals 255.255.248.0. Our interesting octet is the third octet because of the 248. Now we look in the cheat sheet for our decimal mask value and find the corresponding block size, which is 8. Now instead of multiplying 3 by 2048 and dividing by 256, we can just multiply 3 times 8 to get 24, which gives us the same answer. So, you can think of the block size as being similar to the subnet size, except that the block size only relates to a single octet, and that is always the interesting octet of our subnet mask. Because of this, there are only 7 possible block size values. And by the way, whenever you have a subnet mask that doesn't have an interesting octet, just use the rightmost 255 as the interesting octet. This means your block size will be 1. You may recall from Lesson 4 that we showed you how to make a chart to help you remember the IP address classes, but then we told you not to worry about memorizing it. We said that because we can also use the subnetting cheat sheet to remember the IP classes. For this, it may be helpful to have the 0 written down at first. Next to the 0, put an A, and then move up through E, B, C, D, E. To the left of each class is the starting number, and it goes to 1 less than the beginning of the next class, like this. So, if we're in class C, we know that we start at 192 and we go to 1 less than 224, which is 223. Similarly, class A goes from 0 to 127, which is 1 less than 128. We starred the A class to remind us that 0 and 127 are not used. And finally, the first 3 classes have default subnet masks as shown. These you'll just have to memorize, but that shouldn't be too hard. This is the end of Lesson 5, which showed you how to create a subnetting cheat sheet and understand how it works.